Hello, chemistry folks! Today we have four substances in front of us and they're all liquids, but what we want to find out is which one has the strongest intermolecular forces, meaning which one likes to hang out with itself the most, which one is most attracted to molecules of its own kind. So over here we have gasoline, here we have water, here we have ethanol, which you see in your hand sanitizer, and last but not least we have acetone, like you would see in fingernail polish remover. There are a couple of different ways we can figure this out. But first, I'd like you to pause the video and make a prediction. Rank them from greatest to least in their intermolecular forces. I first wanted to take one pipette full of each one of the liquids and place them upon the table to see how they would behave. I started with the gasoline, and as you can see from the video, it made a very large circular shape that was very flat, evaporated quickly, leaving an oily, grimy substance behind. Next was the water. It made a very small circular shape that rose off the table and did not evaporate quickly. Next was the ethanol. It made a medium-shaped circle on the table, didn't rise as much as water, but more than the gasoline, and did not evaporate quickly. Next was the acetone. The acetone left a small to medium shape. It definitely wasn't circular in nature and evaporated very quickly. In fact, I turned up the speed on the camera to show just how quickly it disappeared. Feel free to pause the video now to record down the data that we got from the first part of the experiment. Next, we wanted to see how many drops of each liquid we could fit on top of a penny. We started with gasoline. As you recall, gasoline really spread out on the table. We expected the same thing to happen here, and it was true. We were only able to fit 13 drops of gasoline on top of the penny before it fell off. It doesn't appear to have very strong intermolecular forces. It doesn't like to hang out with itself. Next, we went on to water. With water, as we had seen before, it behaves very different. It bubbles up. You can see it sticking to itself here. We were able to fit 50 drops of water on top of this penny before it finally fell off. You can see the cohesion exist with this substance. Next, we added drops of ethanol to the penny. In this case, it didn't work as well as water, but pretty close, 30 drops. Next up was acetone. I didn't expect acetone to do very well because it had evaporated so quickly, but it really outperformed my expectations. We were able to get 28 drops of acetone to fit on top of the penny before it fell off. Feel free to pause the video now to write down the data. For the last experiment, I wanted to actually find out how long it would take for them to evaporate. So first I put down water. It made its same circular shape. Next, in the bottom right, I have ethanol. Interestingly, it didn't bubble up like it did before. I think it was absorbing energy from the deck planks and overcoming its intermolecular forces to spread out a bit. In the top left, I have gasoline, spreading out just as it had done before. And in the top right, I ended up putting acetone, the thing that had evaporated most quickly before. As we look down at the bottom left, water's still in its characteristic circular shape. In the top right, you'll notice, oh my goodness, the acetone's almost gone. I thought maybe I didn't put enough, so I put a whole nother squirter full of acetone on here. Keep in mind, this tape is sped up, but still, it went away fast. In the top left, gasoline's almost gone at this point, while ethanol's closely behind. Now, all three liquids are kind of in a race to try to get to that evaporation point, while water stays over on the left. In fact, water was taking so long, I went on a walk. While I was out on a walk, the battery from my iPad died and I wasn't actually able to track the final time when the water evaporated. But you can see here as I sped it up even more, the intermolecular forces are being overcome as it loses its bubble shape and starts to spread out. As it gets more and more spread out, the water layer is thinner and it's able to absorb the heat energy that's in the planks and from the sun, and it's going through a phase change going from liquid to gas. Please pause the video now to record down the data. Now, using the data from these three labs, try to rank these liquids from greatest to least in their intermolecular forces.